Good afternoon, everyone. My name is Bussayaphan Siriprasert, a fifth-year pharmacy student in Section 3. Today I'm going to present you a gas chromatography in the subject of techniques in application of analytical instruments to submit to Associate Professor Dr. Suthasinee Thapphasaraphong. The name of selected research paper is Curcuminoids and Essential Oil Components of Turmeric at Different State of Growth Cultivated in Iran. This paper related to the plant extract which analyzed by the gas chromatography and gas chromatography coupled with the mass spectroscopy. The content that I will present to you will be composed of the first one is the principle to describe the principle of selected research paper. The second one is the research paper details, which tell you about the title, samples, objective, the method of analysis, the results, the chromatogram, discussion and conclusions. And the third one is the advantage of this paper. And the last one is the application to describe the application of this research paper. Begin with the principle of this research. Turmeric is an important herb used as a medicine, condiments, and cosmetics. Its main active components are curcuminoids and essential oils. The biomass productions, essential oil compositions, and curcuminoid contents of Curcuma longa are known to be dependent on growth and development conditions of rhizome. To clarify, the biomass productions, essential oil components, and the curcuminoid contents of Curcuma longa of the rhizome are affected by its cultivation conditions, including factors such as nutrient availability, growth media, and climate conditions. To conduct these research papers, plants were harvested at different states of growth, and rhizome fresh and dry weights were measured. The curcuminoids and the essential oils were analyzed by the TLCs and GCMS respectively. Alpha-phenyldirene, terpenoranes, alpha-zingiberine, beta-cyclophenyldirene, R-termerones, and alpha-termerones were the main components of the essential oils. The curcuminoids were detected as curcumin, des-methoxycurcumin, and bis-des-methoxycurcumin. Next one is about the paper research details. The aim of this research paper was to evaluate the curcuminoids and essential oil compositions as well as the curcumin content at the different states of growth of the Curcuma longa rhizome cultivated in Isfahan. And for the sample plant preparation, rhizomes of Curcuma longa used in this study were obtained from the Chulalongkorn University of Thailand on the 5th of February 2002 and cultivated in the University of Isfahan greenhouse. The rhizomes were sterilized for 30 minutes in the Banomuse fungicide and simultaneously the piece cocoberized and the pot were inoculated for sterilization. The uniform rhizome in size, which are 5 to 7 cm in length and 1 to 1.5 cm in diameter, were selected and then were planted on the 15th of February 2006. The growth media consists of perlite and cocoperlite in 10 cm diameter pots. The pots were placed in the greenhouse with temperature set at 30 degrees Celsius in daytime and 25 degrees Celsius in the nighttime, and then a preventive drench of ballot 40% WP at 62.5 ml per 100 liters were applied immediately after planting. Once shoots has emerged, the budded rhizome were moved to a 25 cm diameter pot and kept in the greenhouse in a completely randomized design in 3 replicates. Plants were irrigated using Hochland solution daily to keep the soil moisture almost at the field capacity. Plants were harvested at a different state of growth, which are 2, 4, 6, 8, and 10 months after budding. Harvested plants were separated into leaf, root, and rhizomes, and then wet and dry weight of each plant part were measured. Next one is the method of analysis by gas chromatography. The dry rhizome was grounded to a fine powder using petals and mortar. The essential oil from the powdered rhizome were obtained by the hydrodistillation method immediately after collection. The essential oil were analyzed by gas chromatography and also with the gas chromatography coupled with the mass spectroscopy. The gas chromatography analysis was carried out on a Perkins-Elmer's 8500 gas chromatograph with the FID detectors and a BP1 capillary columns with the 30 m in length and 0.25 mm in diameter and film thickness in 0.25 micrometers. The carrier gas was nitrogen with a flow rate of 2 ml per minute. Then oven temperature was initially set at 60 degrees Celsius and then increased at a rate of 4 degrees Celsius per minute until reached the temperature of 150 degrees Celsius and then increased to 280 degrees Celsius at a rate of 15 degrees Celsius per minute. Injector and detector temperature were set at 280 degrees Celsius. And next one is a method of analysis by gas chromatography coupled with the mass spectroscopy. The mass spectra were recorded using a Hawkless Packard 6890 ms detectors with the EI source coupled with the Hawkless Packard 6890 gas chromatographs equipped with the HP 5 ms capillary column with 30 m in length, 0.25 mm in diameter and film thickness 0.25 micrometers. The gas chromatographic conditions were set as described like the gas chromatography analysis. The mass spectrometer conditions were as follows: ionization potentials 70 eV, salt temperature 200 degrees Celsius. Identification was based on the retention data and computer matching with the Wiley 275.L library as well as by the comparison of electron impact mass spectra with those of relevant reference materials and the literature. And for the results, the gas chromatography coupled with the mass spectroscopy analysis of curcuma longa rhizome were shown. The presence of 6 major peaks as in the figure 1. The 6 major peaks eluded at 4.93, 6.97, 19.34, 20.14, 24.79 and 25.43 minutes, which were identified as alpha-pyridine, terpinolene, alpha-syngiberine, beta-secretpyridine, R-termorone, and alpha-termorone respectively. Simultaneously, 6 minor compounds were also identified. The retention times and COVID index of major and minor compounds are presented as in the table 1. Termorone was one of the main compounds found in the rhizomes and is also believed to be the intermediate for formations of zingiberine and secretpyridine, which are two major secretorbins of the plant rhizome. For the discussion and conclusion, results obtained from this experiment show that the dry weight and curcumin content of curcuma longa rhizome increased over maturation of the plants. Statistical analysis indicate a linear significant relationship between the concentration of curcumins and biomass of the rhizome, R squared equal to 0.91. The smallest monthly variation rates were observed within the February, while the largest one in the November and May. The mean value of the curcumin are different between 4 and 6 months of the harvest. That is different for the weight of the rhizomes at this stage. With regard to the amounts of the harvested curcumin at a different stage of the growth, no significant difference between 8 and 10 months of harvest were observed. This means that harvesting the plants when it is 8 to 10 months old does not make a significant difference in terms of curcumin contents. Therefore, plants can be harvested 2 months earlier, and there would be no curcumin gain for this 2-month delay. And the data presented in the table 2 show the difference in the weight of the rhizome at different states of growth were statistically significant, and also their weight correlated significantly to their curcumin contents. Table 3 indicates that curcuma exhibit higher growth rates in between month 4 and 8. So the results show the time that most appropriate to harvest curcuma longa rhizome in order to obtain the optimal yield of the curcumin. It is recommended that the rhizome in most plants be collected at the end of vegetation period. This research paper showed the advantages of the gas chromatography as the first one, high resolution power compared to other methods, high sensitivity, high accuracy, and the high precision of the results. It can analyze sample very quickly, within minutes or even seconds, and the small sample needed only in microlit or microgram. So the application of this research guides the way to set the conditions and the way to operate the gas chromatography in the real practice. And when interested in the plant extract of curcuma longa, this research paper can be the guideline to tell what and when to harvest to get the high yield of interested compounds and how to extract the compounds from the plant. And this is a reference of the research paper. So this is all of my presentation. Thank you for your attention.